It's about acids, bases, and salts. What are acids?
They are chemicals that neutralize an alkali to make a neutral.
You really have an idea. That's fantastic. Acids are substances that can neutralize a base or alkalines or alkalis, right?
Yes.
By the way, I will tell you what alkalis are. You know, of course, an acid has a low p.
They are soapy in nature, and they are used to make soaps and detergents.
Beautiful, 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 interesting. An acid has a low pH between 0 and 7. You know, you know what pH is? What
Yes.
helps us to tell the acid level or the alkaline level of the substance. Between 0 and 7, a pH of between 0 and 7 is acid. 7 is neutral. From 7.1 to 14 is base. Anyways, we look at all that. And you know, an acid turns blue litmus paper to red. You know that?
Yes.
It turns what?
And alkali told red and
Litmus paper
it
to blue.
blue.
Yeah, beautiful. Acids have a sour taste. You know, when milk goes sour, goes bad, it becomes more acidic. Acids have a sour taste, okay?
Yes.
Alkalines have a soapy taste. Okay, now bases are the chemical opposite of acids. You know that.
Yes.
In fact, bases turn red litmus paper blue or to blue, while acids turn blue litmus paper to red. Bases are the opposite. They turn red. They turn red to blue. Exactly the opposite of acids that turn blue to red. Okay, bases have a high pH from 7.1 to 14. I hope you're seeing what I'm circling.
Yes.
Now, there are special bases we call alkalis. Read out what I just wrote here in yellow.
Bases that are soluble in water are called alkalis.
Yes, bases that are soluble in water are called alkalis. Not all bases are soluble in water. The ones that are soluble, that can dissolve in water, are the ones we call alkalis. Generally, they are all called bases. The ones that can dissolve in water are called alkalis, okay? I hope that's fine.
Yes.
Then, of course, bases have, like you've said, bases have a soapy taste. Examples of alkalis are stuff like calcium hydroxide and many other ones. You have calcium hydroxide, the note continues here, sodium hydroxide, etc. Now, examples of bases are read what I'm circling here. Most oxides of metals are bases. Examples
Most oxides of metals are bases.
like
Examples: sodium
sodium oxide.
oxide, etc.
Another one, read number 3.
Most detergents
No,
and
you've not
washing
read
agents.
you've not read number 2.
You said read number three.
Oh, sorry. Let's look at number
Most
2.
hydroxides of metals are bases, e.g., potassium hydroxide, etc.
And number 3 now.
Most detergents and washing agents are bases.
Like you know, all those detergents. So let's look at examples of acids. I shouldn't have gone to that part until I had finished this, but we can still look at it. Examples of acids. We have what we call organic acids. These ones are obtained from plants or animal products, and they are usually weak acids. Like citrus acid, you get that from fruits. Lactic acid, you get that from milk. Vinegar, they are all examples of organic acids. Did you get that?
Yes.
Organic acid are obtained from what? From where?
Organic acids are obtained from plants and animals.
Okay. Examples are citric acid,
found
lact
in fruit,
in fruits,
citrus fruit, and lactic acids like in milk.
and then you have
And there's
vinegar.
also vinegar.
All right. They are usually weak acid. Then we have inorganic acid. Those ones are manufactured, and some of them are usually strong acids. Examples are hydrochloric acid. You find hydrochloric acid in the stomach. Do you know? I will talk to you about that. That's why
Yes.
sometimes we say someone has high stomach acid, and so he will need to use antacid, which is a base. We'll talk about that. Then of course there is sulfuric acid, there is nitric acid. I've already told you about bases. Now, I said something about alkalis. Read what I wrote in green.
Note that all alkalis are bases, but not all bases are alkalis.
Remember what alkalis are. What are alkalis?
Alkalis are bases are that can that are soluble in water.
Yes, bases that can dissolve in water. What it means is not all bases can dissolve in water. The ones that can dissolve in water are called alkalis. So alkalis are a few or certain bases that can dissolve in water. You know, some don't, and they are just generally called bases. The ones that can dissolve in water are specially called alkalis. So all alkalis are bases, but of course not all bases are alkalis. Just like saying all Nigerians are Africans. But are all Africans Nigerians?
No.
Okay. But are all Nigerians Africans? I'm asking you, are all Nigerians?
Yes.
Yes, if you are a Nigerian, obviously
Yes.
you are an African.
Yeah.
If you're a Nigerian, you're an African, but you might be an African and not be a Nigerian. Nigerians are like alkalis that are part of Africa, but there are some Africans that are not specially Nigerians or alkalis, just like there are bases that are not alkalis. Okay, let's go to the next page where we talked about something else. Next page. Are you there?
Okay.
Next page
Yeah.
talks about pH values. The pH values, you know, it ranges from 0 to 14, isn't it?
Yes.
It shows how weak or how strong an acid is. Please undo. You shifted it a little bit. All right. So, the lower the pH value, the stronger the acid. I hope you know that. And the higher the pH value, the weaker the acid. Or the stronger
Yes.
the higher the pH value, the stronger the base. The smaller the pH value, the weaker the base. For instance, let's look at it. You know, 7 tells us what? A pH value of 7 means what?
Huh?
A pH value of 7 means what?
It's neutral.
Neutral. Good. You know that. Interesting. Now, a pH value of 2 and 5, which one is a stronger acid?
As 2.
2 is stronger than 5 because the lower the pH value, the stronger the acid. A pH value of 9 and 13, which one is a stronger base?
13.
13 is a stronger base because as you are moving to the right, the base gets stronger. As you are moving to the left, the acid gets stronger. I told you about stomach acid. This is just an additional information. Some of the symptoms of stomach acid, like bloating, heartburn, diarrhea, unexplained weight loss, but don't bother about that. All right, I need to show you this. This rule is important. I will go through it, and then we will look at a few things. Please, you pay attention to these rules. They are very important. They are very important.
Okay.
These rules are very important. Now, rules. Metal plus acid gives what?
Um,
Undo. You shifted it slightly. Okay. Metal plus acid gives what?
Salt.
Yeah, salt. If you didn't finish it, go ahead.
Plus hydrogen.
Yes, metal plus acid always gives salt plus hydrogen. Give me an example of a metal.
Iron.
Iron, magnesium. For instance, magnesium plus hydrochloric acid will give you what? Read this.
Hydro
Yeah, I have said magnesium plus hydrochloric
magnesium
acid.
chloride
You didn't finish it.
plus hydrogen.
Now, where is the salt here? Yes, magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. Where is the salt here? Which one is the salt in these things that are given?
Magnesium chloride.
Good. Magnesium chloride is the salt. Hydrogen is the gas that will be given out. Remember, metal plus acid always gives salt plus hydrogen. If you notice, if it is with hydrochloric acid, it will form something chloride, and then hydrogen will be released. Let's check another one. Look at this example B. Read it out. You are doing very well. Read it out. Let's go. Read it out. Example number 2. Let's go. B. I'm talking about 1B. Let's go. Example B. Let's go. Let's be fast.
Sodium plus sulfuric acid equals to sodium sulfite plus hydrogen.
Sodium sulfate plus hydrogen. When you are working with some sulfuric acid, it's going to give something sulfate, like metal sulfate, then plus hydrogen. If you're working with hydrochloric acid, it's going to give metal chloride, then plus hydrogen. If you're working with nitric acid, it's going to give what?
Something nitrate.
Plus hydrogen. You are fantastic. You see, we're working very fast. Remember the rule. What's the rule again? The rule again is metal plus acid is equal to salt plus hydrogen, okay?
Yes.
That's rule number 1. Let's look at rule number 2. Read rule number 2. Read rule number 2.
Acid plus base or alkali equals to salt plus water.
Acid plus base or alkaline gives salt plus water. Now let's look at some of the examples. Read out example A. Hydrochloric acid.
Isn't that metallic?
Hydrochloric acid is an acid plus sodium hydroxide is a base. Remember when we were talking about examples of base, I told you a metal hydroxide is a base. Yeah. So go ahead, read it out.
Hydraulic acid plus sodium hydroxide equals to sodium chloride plus water.
Plus water. Because acid plus base or alkali gives salt plus water. Is that clear?
Yes.
Are you taking note of these laws? They are very important. Read example number 2.
Metal.
Example number B, 2B.
Sulfuric acid plus calcium hydroxide equals to calcium sulfate plus water.
Are you seeing the way the thing is working? If it was sulfuric acid, it's going to be metal sulfate, right? And of course, plus water if it was with base. Acid plus base is equal to salt plus water. The salt, tell me the salt in examples A and B. What's the salt in example A and what's the salt in example B?
So A is sodium chloride.
Beautiful.
And B is calcium hydroxide.
Are you sure? B.
And B is calcium sulfate.
Calcium sulfate is a salt in B. Sodium chloride is a salt in A. Now example C, 2C. Nitric acid plus potassium hydroxide will give
potassium nitrate plus water.
Because it's acid plus alkali that gives salt plus water. Compare it with acid plus acid plus metal or metal plus acid. What does metal plus acid give?
Salt plus hydrogen.
Salt plus hydrogen. Metal plus acid gives salt plus hydrogen. But acid plus alkali gives salt plus water. Both of them have salt. In fact, virtually all of them will have salt. The only thing that changed is instead of hydrogen when it is only metal, it's going to be water when it is with base. Same metal and acid, now base and acid. All right, let's go to rule number 3. Read out this rule number 3. You're doing very well. Metacarbonate, like a metal with carbonate attached to it. Like calcium carbonate, iron carbonate, aluminum carbonate. Okay? Go ahead.
Metal carbonate plus acid equals to salt plus water plus carbon dioxide.
Okay, I need you to be all right. You're getting this. Metal carbonate plus acid will give you salt plus water plus carbon dioxide. Give me an example of a metal carbonate.
Calcium carbonate.
Calcium carbonate.
Plus hydrochloric acid.
That is like saying metal carbonate plus acid. Yes. We give you what?
Calcium chloride plus water plus carbon dioxide.
Yeah, it's almost like the previous one we did. The only additional thing here is what?
Carbon dioxide.
Yeah. Whenever you carry out this experiment, you see carbon dioxide will be bubbling out. Like that's what you get in fizzy drinks. That thing that bubbles out is carbon dioxide as a result of the reaction. So another example is sodium carbonate plus sulfuric acid. Let me see if I cover it, if you will be able to get it, though you will still take some questions. I've covered this. Let me see if you'll be able to get it. Sodium carbonate plus sulfuric acid we give you what?
Sodium sulfate.
Good.
Plus water plus carbon dioxide.
Excellent. Sodium sulfate plus water plus carbon dioxide. That's cool. Now, I think this might likely be the final one. Number 4, read it out.
Metal oxide plus acid
gives what?
Equals salt plus water.
Salt plus water. Metal oxide plus acid gives salt plus water. There's a rule like this. There's a rule that gives salt plus water. Do you remember that one?
Acid plus base.
Yes. Acid plus base also gives salt plus water. You can see it here. Acid plus base also gives salt plus water. Acid plus base also gives salt plus water. And metal oxide plus acid also gives salt plus water. That means this base has to be a metal oxide, or this metal oxide has to be a base. Can you see it?
Yes.
Because acid together with base gave salt plus water. And then acid together with metal oxide also gave salt plus water. That means metal oxide here is a base. In fact, most metal oxides are bases. Right?
Then how come you want to aren't?
Pardon? Pardon?
If most of them are bases but it's a base, then why aren't the other one bases?
Excellent. Excellent. There are some that form what we call amphoteric oxides. They are both bases and acid. That's beyond your scope. There are some metal oxide like aluminum oxide. It can act as a base. It can also act as an acid. Zinc oxide, those things are beyond your scope. You will get to learn them when you get to higher classes. Aluminum oxide, for instance, aluminum is a metal. So aluminum oxide is a metal oxide. But it forms something that behaves like a base and also behaves like an acid. So we call that amphoteric oxides. Now let's look at a few examples as we conclude the rules. Read this. Read this very quickly. Examples.
Sodium oxide plus sulfuric acid equals to sodium sulfide plus
Sulfate. So we'll say
sulfate
sodium
plus
sulfate
water
plus water. Then calcium oxide plus hydrochloric
plus
acid will give you
hydrochloric acid
what?
equals calcium chloride plus water.
Yes, if it is with hydrochloric acid, it will give metal chloride. If it is sulfuric acid, it will give metal sulfate. If it is
Okay.
nitric acid, it will give metal nitrate or nitrate, if you like. By the way, you see this rule 2, that rule 2 we talked about up here, this rule 2. Read out rule 2 again.
Acid plus base equals to salt plus water.
Acid plus base equal to salt plus water. This rule 2 is called neutralization reaction, because acid is neutralizing base to give salt and water. So it's a neutralization reaction, okay? Now sodium chloride is the table salt that we know. Sodium chloride is table salt. Okay, you know your common salt in the house. That's
Yes.
sodium chloride. Look at this. I would have cleaned this for you to do, but there are other examples I can give. For instance, aluminium carbonate plus nitric acid. Of course, it will give aluminium nitrate plus water plus carbon dioxide, because it is metal carbonate. Potassium plus hydrochloric acid will give you potassium chloride plus hydrogen, because this one is metal plus acid. Did you get that?
Yes.
All right, go to the next page. There's something beautiful for you there. No, next page again. Let me see. I think I need to move this a bit further so that I can reveal it better. Yeah. All this, you may need to zoom in to see it properly. It gives you examples, and then it tells you what you like. Magnesium oxide plus nitric acid, what will it give? And all this one, you will fill it in. I think it's an exciting work. You will do very well in all of them, isn't it? So you go down again, you see this one. Magnesium oxide plus nitric acid, what will it give? Anything that is not provided, you can fill it up. Use your pen so that you can write it. That's for your practice question, okay?
Yes, sir.
Then all of these. Hydrochloric acid plus lithium hydroxide will give what? Stay on the Jamboard, stay on that page. Okay, you are still there. And all of these. You take your time and look at all of them.
Okay.
See this one too. Let's even look at this one. Look at this one I'm circling. Read it out.
Zinc carbonate plus sulfuric acid.
What should it give?
That is zinc sulfate plus carbon dioxide plus water.
Awesome. Zinc carbonate plus sulfuric acid will give zinc sulfate plus carbon dioxide plus water. You are such a fantastic scientist. Don't you feel like one?
Yeah.
Look at how you're getting this thing so easily and so quickly. Have you learned them before?
No.
Oh, that's fantastic. Anyways, you can see these other ones. You can also do this, like calcium plus hydrochloric acid, what will it give? You know, some examples are given.
Which one?
All of this on this page. All of this on this page. You will really enjoy them by the time you do all of them. And then these ones. Everything on this page. I think I might need to move this back again to keep it the way it was, because I kind of crossed some things. Okay, so that's it. Everything on this page. The rule will be given, and then you just follow the rule and get what you need to get. That is that. I think there are other practice questions on the next page, but if you're able to do all this one, go to the next page, you will see some other ones, but those are just practice questions. Go to the next page. You see other practice questions. Please go to the next page. I need you to see it. Just have a look at it. Just have a look at it. Just have a look at them. Yes. Let's have a look at them. There are some things you can read, study about them, and then, just have a look. Just have a look for further practice work. I think there's one on the next page. I will talk to you very quickly about stomach acid. Please go to the next page. Let me say this one very quickly. Very quickly. Go to the next page. The next page. Yes. Read this. You may need to zoom in. Read this: acid indigestion.
Okay. Stomach contains hydrochloric acid. Too much acid causes indigestion.
And when people have stomach acid with heartburns and all that, they are given what we call indigestion tablets. Some call it antacids. Antacids are actually bases or alkalis. Antacids. Antacid, like anti-acid. Antacid. Anti-acid will be opposite of acid, right?
Yes.
To help to neutralize the stomach acid. They are weak alkali to neutralize the acid. Do you know that the sting of certain insects contain certain chemicals, like the sting of a wasp is alkaline? So if you want to treat it, what should you do?
Put acid.
Use a weak acid like vinegar to neutralize it, is it not?
Yes.
The sting of a bee is what?
It is alkaline.
No, the sting of a bee sting.
Acidic.
So if you want to treat it, what should you use?
Weak alkaline.
You use a weak alkaline to treat the sting of a bee because it will neutralize it. A weak alkaline like sodium bicarbonate. Okay, there are times when the lakes, like rivers, they become too acidic. Like because of acid rain falling onto soils and lakes, they can make them too acidic, or even soils. To neutralize the acid, what do they use? Read out what I'm just circling. Read out this thing I just circled here. Read out what I just circled here.
Yes.
Read out what I circled here.
Powdered limestone is spread onto soil to neutralize acid.
To neutralize acids. Blocks of limestones are added to neutralize acid in lakes. If it is in rivers, in lakes, we use blocks of limestone, to neutralize the lake, the acid. If the soil gets too acidic, it can affect plants. If the river gets too acidic, it can affect animals, fishes that live in the river. So they need to be neutralized using usually limestone. When it is on the soil, you use powdered limestone. In rivers, you use blocks of limestone. So when you do that, you may need to also answer this question. So this one will also be part of what we look at as a practice question. Okay? Any question?
No.